Hey guys, Miss Sam's here from my house. I am going to be going over. Hey, now y'all can see me. I'm going to be going over our systems of inequality. So very very similar, very familiar to systems of equations whenever we graph two. And we found the solution system of inequalities is going to be having us graph two inequalities at the same time. So I thought I would give us a nice break and doing systems of inequalities, starting that off in the introduction in Desmos.com. So we can really understand kind of why the double shading is happening and what this is really about to look like before just graphing it by hand. So I'm going to highlight number one. I'm going to use Control C. Again, my keyboard was Control C to copy. That way, whenever I go into Desmos, all I have to do is hit Control V as in Victor to paste. So you can see that my particular solution is happening below the line. I have so many tools. Okay, it is happening below the line. Really? Okay, it is happening below the line here. There we go. It's like, I am not restarting this video again. And then the next piece, I'm going to use Control C to copy this area as well for that particular inequality as well. And then we're going to use Control V to paste. Okay, so now I notice that that particular solution is being graphed. In this area as well. Okay, so it was being graphed above. Okay, this one was being graphed in this area. So where is the section that they share? So the section that they share in shading happens to be this piece right here. And my face in my little picture there is about to be in the way. But all of this section over here is the section that they share. So all of those are going to end up being a solution to my systems of inequalities, okay? Meaning that all points in that section right there is true for the first inequality and true for the second inequality, okay? And we can kind of visualize this if I was to clear off and clean up this. You can kind of see where they overlap right here in that same area, okay? So that section of the inequality graph is where my solution is located at, okay? So with all of that said, we're going to end up showing algebraically in just a moment how that is true. But first, I'm going to make sure I walk you through how to download this so you can submit it into today's assignment. So you can do it as a link, but if you hit export image, I don't mind if it's a medium thin, and you're going to download the particular image, and then you are going to click and drag into the table. Okay, if you put it inside the table, it'll be small enough where it's not going to blow up your entire image, okay? Now we're going to go back into Desmos, and we are going to clear this out, and we are going to start fresh for the next one. Again, I'm going to do Control C on my keyboard and Control V to paste. Now you are more than welcome to type them in. So if I was to type in y is less than, I would go down at the bottom to the keyboard feature and do y is not at that graph. I did it earlier too. I would do y is less than, and it was negative 1/3. So negative 1 divided by 3. Click off of it so that you're not below writing in the denominator, the bottom portion of that fraction. And then it was x plus 1. So x, and then we are going to add 1. Okay, So here you can see again where it's being double shaded. You can also use these particular icons here and unhighlight the solution and the graph that is being graphed there on Desmos, or you can also graph nothing and then you can turn them back on one by one. So something that I noticed is you can actually move them too, but I didn't mean to do that. Okay. So something that I noticed is, was the first one underlined? Oh, this one was greater than or equal to. It didn't carry over. There we go. Okay. So something that I noticed is the very first one has the solution shaded above the line, okay? And then the second thing that I notice is on the second one is shaded below. So let's go ahead and graph them together. Where is the part that they share their shading? So the particular part that they share is located again, I am terrible at drawing lines. Why don't I use the line tool? Does that work? Nope, that's just putting dots places. What about that? Nope. Okay. That was an epic fail. Okay, so anyways, apparently that's not a line tool. I don't know. But this particular spot right here is where they share their shading. Okay. So when you are asked eventually to graph these by hand, you would shade all of this particular piece in. So here is where the solutions lie. And I say solutions because they are inequalities. So there are multiple points that are able to make these inequalities state a true statement. So going into all of that, I am going to go ahead and download this image. So we're going to use the export, the little share button, export it all. While that's happening, I'm going to clear off my writing and then make sure I go in here and I'm going to insert my picture. Okay, so with all of that being said, we are also going to be making sure that we can algebraically show why there is double shading. So why is there so much shading going on with our systems of inequalities? So directions, explain algebraically. So that means that we're using numbers, we're using math, we are plugging in the points that I'm asking you to plug in, and we're going to be showing our work here algebraically. So you get out your notebook, take out a pencil, make sure you're writing this, and then yes, you have to upload a picture. I'm actually going to be writing on the screen though. You are going to be uploading the picture. So we notice that the double shading happened in, let me get my web paint tool going on here again. So the double shading did include the point 0, 0, okay? So let's prove, and again, you have your own set on your independent practice today. I'm going to walk you through how to prove that 0, 0 is a solution to both of them. Okay, so again, I'm going to undo that so I can show my work. Okay, so for the very first one, if I was to plug in the point 0, 0, and I'm going to use the 2x plus 2 first. So is 0 less than 2 times 0 plus 2? So is 0 less than 2 times 0 is 0, adding 2 is 2? Yes, that is a true statement. Okay, now the second equation, I'm still going to use 0, 0. So is 0, and I didn't switch colors, is 0, there we go, greater than or equal to negative 0 minus 3. So negative times 0 is just 0. So is 0 greater than or equal to negative 3? Yes, it is. So that is why you have that double shading in that area. That point was true for both of them. So all of that shading happened to include the point 0, 0. Because 0, 0 was a solution to both of them. Okay, now if you take a look at the second graph as well, 0, 0 was also a solution or located in the double shading of that particular graph as well. So again, we are also going to prove why 0, 0 was a solution to both of those, or why there was double shading to include the point 0, 0. So I'm going to go back, or try to go back to the other color. Okay, so again, I'm going to use the point 0, 0 for this particular equation first. So it is 0 greater than or equal to 0 minus 1. So is 0 greater than or equal to -1? Yes, that is true. The next one, and I did it again. The next one is 0 less than or equal to -1/3 times 0 plus 1. So is 0 less than or equal to 1? Yes, that is also a true statement. Okay, so I hope I haven't lost you yet. That's why we have double shading in that area to include 0, 0, because it is a true statement for both inequalities. Okay, now the next part of what that we're proving is there's another point besides 0, 0. So let's algebraically show why 1, 1 is also a point. So if I was to go up here, my point 1, 1 would fit in right there. Okay, so 1, 1 is also a solution, and we need to prove algebraically why. So if I was to plug in 1, 1, okay, to the first one, is 1 less than 2 times 1 plus 2? So is 1 less than 2 times 1 is 2 plus 2, 1 is less than 4. That is a true statement. Okay, on the next one, I need to also prove 1, 1. So 1 goes in for the y, greater than or equal to, -1 goes in for the x, -3. So is 1 greater than or equal to -4? Yes, that is a true statement. Okay, which is why my shading also included the point 1, 1. Okay, now the next one was asking for the point -3, 1. So if I was go to -1, 2, 3, +1, so that point right there is a solution. It's located in the area that is double shaded or has an overlay. Okay, and we are going to walk through the point -3, 1. Is it true for both of them? My guess is yes, but again, we're algebraically proving today. So -3 is going to go in for x. 1 is going to go in for y, because remember your points are listed as an x and y value. So for my very first one, I have 1 is greater than or equal to, x is -3 minus 1. So is 1 greater than or equal to -3 minus 1? Is 1 greater than or equal to -4? Yes, that is a true statement. Okay, for the second one, again, using the same point, but 1 is going to go in for y. Is 1 less than -1? I'm going to write this as a vertical fraction. And then multiplied by my x value is -3. Hopefully you're all okay with me changing that to a whole, or not the whole number to a fraction there, so I can do my easy multiplication. And then I'm going to add 1. So is 1 less than -1 times -3 is a +3. 3 times +1 is a +3. Add 1. So is 1 less than, bear with me, 3 divided by 3 is 1 plus 1. Is 1 less than 2? Yes, that is a true statement. So that would be why the shaded area also included the point -3, 1 in the solution area, or the solution section, or the one that was double shaded, to represent the points that are a true statement to the inequality that is listed. Okay, I'm going to clear this off, and we have a couple more things to prove. So the very last section of today's assignment is where you are going to be proving or showing at 2 points being the solution, okay? So we already have shown why 1 is a point. You can use that exact same work today. And we're also going to be showing why another point is true. So like the shaded area includes multiple points, points that are not even shown on the graph. But again, you just need to have the understanding, and we're going to be showing it algebraically. So we have shown above why 1 was a point and 0 is a point. We're going to take it one step further, and we are going to show why another point is true. Okay, and so that point we're going to use is 3, 2. So for my very first equation, I'm going to use the y value of 2 is less than 2 times 3 plus 2. Okay, and again, I'm using the first equation. This is my y. This was my x. So is 2 less than 6 plus 2? Is 2 less than 8? Yes, that is a true statement. And on the second one, I'm going to be using the same point, 3, 2, but I'm going to be using this particular equation. So 2 was my y value. Again, it was my y value listed right there. Is greater than or equal to negative 3 was my x minus 3. So 2 is greater than or equal to negative 3 minus 3. If I do the change, that becomes negative 6. And is 2 greater than negative 6? Yes, that is a true statement. So as I scroll up, that would be y, and an explanation of why. 1, 1, and 1, 1, and 3, 2 was also a solution. If I can scroll up, there we go. And why it was in the area that was double shaded, okay? So I hope this video has helped you. Again, my point was 3, 2. 1, 1, yeah, 1, 1, and 3, 2. So last recap, let's take a look here at number 1 as I scroll my screen down. Okay, so the points that we looked at as to why they were a true statement. Okay, we looked at the point 0, 0. We looked at the point 1, 1, and 1, 2, 3, 1, 2, and 3, 2. Okay, all of the points in this double shaded area right here, all of them would end up showing that this particular inequality, even the ones down here, would be a true statement. So all of those happen to be solutions to the systems of inequalities, okay? Hope this video has helped you. Again, we're using Desmos.com. Please don't go through the hassle of graphing them by hand. That's going to be coming with me on Wednesday, because again, we have a live Zoom session. We'll be able to practice this together before I release you to do them on your own. And then we are going to be proving algebraically today why there is certain, so like why there are multiple solutions, why is there so much shading happening with systems of inequalities, and this didn't happen with systems of equations. So if you need me, I'm a private comment away on Google Classroom or just an email. So make sure you reach out to me if you need anything, and don't forget we have a live Zoom Wednesday at 9 a.m.